The laws of thermodynamics can help explain various processes that occur on Earth. Specifically, the first and second law of thermodynamics can be related to climate change and shed light on why climate change continues to be exacerbated. The first law of thermodynamics states that the total energy of the universe is constant. Energy is always conserved and it cannot be created or destroyed. The second law states that for any spontaneous process, the entropy of the universe increases. In regards to climate change, whenever energy is converted from one form into another, some of it is given off as heat. Heat is the highest state of entropy, meaning it has high disorder or randomness. Unless this heat can be dissipated, temperature will rise. A certain amount of solar energy falls on Earth's surface and creates heat. Unless the same amount of energy is dissipated back into space, Earth will warm. As I mentioned before, the second law of thermodynamics states that energy cannot be destroyed. Matter and energy can be transformed, and energy can be converted from one form to another, but the total amount of energy must remain constant. Therefore, some solar energy will be trapped in our atmosphere. Now, with the mass increase of CO2 in our atmosphere from anthropogenic sources, certain gases in the atmosphere, especially carbon dioxide, have the effect of trapping thermal energy on Earth. The CO2 in our atmosphere absorbs infrared light from the sun, which gets converted to kinetic energy, which results in heat or thermal energy. As CO2 content increases, more light will be converted to thermal energy and climate change will be exacerbated. The image on this slide shows how the greenhouse gases in our atmosphere traps heat. The process of solar energy entering our atmosphere is spontaneous and exothermic because it adds heat to the surroundings and increases the entropy of the surroundings. Any spontaneous process is irreversible because there is a net release of energy. Therefore, heat released into the atmosphere cannot be taken away. The warming of our atmosphere has adverse effects on our weather patterns, oceans, and ecosystems. All of these factors are interconnected and affected by each other. The absorption and movement of energy on Earth is related to the ocean-atmosphere system. Let's start by talking about our oceans. Our oceans have a massive effect on the regulation of Earth's temperature. Oceans have acted as a huge heat sink, which has kept land temperatures from drastically rising. Water has a high specific heat capacity, which means that a considerable amount of heat energy is required to raise its temperature. Land has a lower heat capacity and can be heated up or cooled down much easier. The high specific heat of water has helped to moderate the increased heat load to some extent. However, the world's oceans are warming by nearly a full degree of Celsius over the past half-century. The figure on this slide shows Earth's total heat content, and as you can see, the ocean is holding much more heat than the land in the atmosphere. As the ocean slowly absorbs more heat and warms, the water cycle will be affected, weather events will become more drastic, and increased rainfall and ice melt will occur. Ocean currents regulate the global climate, helping to counteract the uneven distribution of solar radiation reaching Earth's surface. Without currents in the ocean, regional temperatures would be more extreme. Ocean currents work together to move heat and fresh water across the globe. As you can see on the diagram on the slide, warm water moves towards the poles and cold water moves towards the equator. However, due to climate change, glacial melt in the poles is adding excess fresh water to our oceans and causing ocean currents to slow down. This is because the fresh water reduces the salinity of the oceans and therefore the density of the water. This less dense water does not sink, causing less cold water to be driven towards the equator. As the ocean currents and weather patterns change, there will be more frequent and severe natural disasters. These disasters will negatively impact humans in all aspects of life, along with organisms and their habitats. Right now, many coastal communities are being affected by sea level rise and increased storms and hurricanes. Other areas are being affected by extreme heat and droughts. Both ocean and land species are being affected in numerous ways. One specific issue that is directly related to increased CO2 is ocean acidification. When the ocean absorbs CO2, the pH decreases and the amount of carbonate ions also declines, which makes the ocean more acidic. pH is an essential component in many of life's processes. In this situation, the increased acidity is causing more dissolution of the calcium carbonate structures, making it more difficult for these calcifying organisms to form their skeletons. Coral reefs have calcium carbonate structures, and they are facing a major threat from ocean acidification. Coral reefs are home to thousands of marine species who rely on this place for food, shelter, and a place for reproduction. Reefs also protect our coastlines from erosion and flooding. As you can see, there are a series of effects caused by ocean acidification. Ocean acidification is just one of the many examples of how climate change is impacting our Earth. After discussing the different effects of climate change, I hope you can see how the laws of thermodynamics explain why and how these events are occurring, and help us understand how heat interacts with the universe. To recap, whenever energy is transferred or transformed, some of it is given off as heat. This excess heat increases the randomness or disorder of the universe, meaning the entropy of the universe increases. This also tells us that the excess heat trapped in our universe due to greenhouse gases will continue to warm Earth and cannot be destroyed.